So we left off here on solar power plants. Basically, there's really two types of solar power plants. Your typical PV, what we learned right here, solar power plant, which basically is going to take photovoltaic cells, line them up over large, and any power plant is going to take up large amounts of space on land because they need a lot of these solar collectors. The sun's going to come in, cause the electrons to move. It's attached to a generator and sends an electric current, which could power your home. The second type is a little bit different. It's called concentrated solar power station. It works like a steam engine. You're going to see a lot of mirrors, a lot of reflectors. Sometimes they even use like solar dish, like a satellite dish, but full of solar panels, you could say. And what they do is collect heat. And then the heat gets transferred over to this receiver, which is either going to have water or a liquid. So oftentimes instead of water, there's a liquid in there, which is like an oil, which heats up to produce steam, again, to spin the turbine, to send electric current. And it's going to consist of the same energy transformations here, which is solar to, I'm sorry, not here. This would be the PV cell, solar to mechanical to electrical. And here it would be solar to heat to mechanical to electrical. Okay, so the power station is just like anything else, but the starting energy is sun. This is something I just saw, which is interesting, and I'm wondering if this is going to kind of take over. This is happening all over the world now, and it's happening at a rapid rate, where people are creating these floating solar power stations. I'm not going to get into advantages and disadvantages, but I'm sure you could see major disadvantages for like the ocean. But believe it or not, it helps reduce evaporation, which they always consider an advantage. But again, I'm not going to get into that. What I am going to talk about is advantages and disadvantages of solar power in general. I need you to keep in mind, and I skipped over this slide, that don't forget that passive solar energy is the most efficient. Here's a diagram straight from your book comparing nuclear energy to passive solar. Passive solar, 90% of the energy is passed on. And I know you're thinking of law of thermodynamics and you can only get 10%, but this is called transmission energy because it's direct versus we talked about nuclear being the least efficient. Please try to remember that. But when we're using solar active, these are what we're describing. Even passive advantages, you're not going to need any water. Like almost every system requires water. In solar passive, no water is needed. In solar directly used in your home, no water is needed. The only time water is needed is when we use concentrated solar power stations. So they consider most typical solar power an advantage because limited water is needed for most of them. I mean, no water. It can be used directly in your home, so you could apply solar panels to your house. That's an advantage to solar, wind, biomass. So a lot of them, and I might have not mentioned them in all of them, but I want you to think of that. When you could use it directly in your home, it's definitely a positive thing. But for the production of electricity, not just heating. And then there's little maintenance, which is important to consider. Remember that I told you that all renewable energy has a high initial cost, but overall at the long run it pays off. They actually say that solar energy, by the time it pays off, you'd have to have lived in your home for a really long time. So take that into consideration. Disadvantages, you got clouds, you got nighttime, and the system doesn't work without direct sunlight. So there's going to be a need for a backup, especially during the hours of the night. So a lot of people will still be connected to a utility grid in order to produce power. There's also technology being converted so that you can store this power that you collect during the day, especially in massive heat days or where the sun is shining bright. You could collect and actually send it back. So that could be considered an advantage. If you have an efficient backup system, you can actually store energy, give it back to FPL, and actually make money. Again, that's new technology in the works. All right, so my last form of renewable energy is geothermal, and I'm using pictures from the US because they're so pretty. This is actually Yellowstone, and I want to show you because they almost look like fake sites, something you might want to consider to visit. Here's one in Nevada. These are geothermal sites, and what that means is you've got geo means earth and thermal means heat, so heat from the earth, and it can be used for direct heating in your home, and it can be used to produce electricity. So the usage for geothermal will cover our needs for heat and for electricity. Where in the world, instead of giving you areas, I want you to know that the best place to tap into geothermal energy is around here, which is the Ring of Fire. I know it's associated to, well, if you remember, to tectonic plates, but why do those plates shift is because the heat in the earth rises, applies pressure to these plates once it spreads out and cools, and then causes the plates to shift and volcanic eruptions to occur. But that's where we could get the most heat, so keep that in mind. How do we get this heat? So we can have what you see here, which is direct steam or geysers coming from the earth. These are hot rocks, and I'm showing you up here, but realistically, geothermal hot rocks are located deep in the earth. I just wanted to give you this picture of a beautiful hot water spring, which also has massive amounts of heat that can be used to produce electricity. So these geothermal heat pumps will basically be used for heating your home. So what happens is you're either going to tap into the hot rocks, you're either going to tap into hot fluid, but you're going to send pipes underground to this geothermal energy, and water is taken directly from some source and then recycled. So it's a very efficient system. This is an open loop, and these are closed loops, where the closed loop is basically you're using the same system throughout, and it works invertedly. So during times that you need to heat, it'll work in one direction, and times you need to cool will work in another. Geothermal power plants, again, typical. We want to go back to our steam engine, right? So we're going to tap into the heat. Somehow we're going to either add water to this heat. So if we tap into the hot water rocks, we're going to add water so we could produce steam, or we can use the steam directly generated by geothermal power, right? So depending on our starting point, if I start with a geyser, I already have my steam. And then that spins a turbine, which is attached to a generator and sends electric current. So when you look at this process, think of what our starting point is. If I'm starting in a hot spring, I want to collect that heated water, add cold water to produce steam. If I'm going to tap into the heat within the Earth's crust, I'm either going to collect it or add water to meet that heat to produce steam. Okay, so try to keep those processes in mind. Advantages, we can use it directly in the home. As you see here, this is an actual geothermal home. And then again, you can use it for heating directly in the home, and it can cool during the summer your home and warm it during the winter. And this is just a little GIF that shows you how that process works. Disadvantages. Believe it or not, these geothermal plants are pretty noisy. You're talking about an area of high heat producing geysers, but there's noise pollution and there's odor pollution. And the reason there's odor pollution is because this geothermal energy is actually one of the few renewable sources that has poisonous gas emissions, sulfur being the main thing, and of course carbon dioxide, because we know that's trapped down there. But this sulfur can be a toxic gas for the atmosphere and also cause a foul odor because sulfur has a strong smell. They do think that tapping into this energy at rapid rates can cause it to become potentially renewable and can be like tapped out. So we got to be careful with the way we use this energy. And then, of course, we don't have a lot of sites available. So what happens is when you tap into geothermal energies around here and you're trying to power an area over here, they got to create these pipes across lands in order to distribute this heat or distribute the energy or build the power station. So a lot of power stations won't be built here and they might be built out here, and then that causes the problem of trying to transfer that energy, which causes it to be less efficient. Again, you could look at this from your book. So we've talked about all the renewable energies, and we got to think about